Unit 3B, Error in Measurement. Error is essentially a mistake in making a measurement. Every single measurement made in science other than counting will have an error in it. Error is not uncertainty, which is something we will talk about in a later lesson. The three types of error that we will look at are systematic error, random error, and human error. Systematic error is a mistake in the measurement that is the fault of the device or the tool. Some examples of this may be a tape measure that has been stretched or a scale that has been poorly calibrated. If you repeatedly measure with the same device, then the error will not be detected. Random error is a mistake in a measurement that seems to occur without reason or cause. Random error may be detected with repeated measurements. Where using the same equipment making the same measurements, you find yourself with different results each time. Examples of this are measuring wind speed or ambient sound levels. Using the same equipment to make multiple measurements in a short period of time will produce different results each time. This can be minimized by taking the average of those measurements. Finally, there's human error. This is a technical mistake made by the user. This is not an acceptable form of error in science and must be minimized by controlling variables, calibrating equipment, and using devices properly. If a scientist identifies human error in their practice, they must correct the error and repeat the experiment. Repeated measurements may or may not expose this, but a minimum of 3 measurements are necessary to identify it, 2 to identify the error, and a third to determine which is the bad measurement. You can calculate error a few different ways. Absolute error. Absolute error looks at your measurement and compares it to a universally accepted standard value for that measurement. Calculating the difference between your value and the accepted value leaves you with the absolute error. An example of this is the speed of sound. The universally accepted speed of sound is 352 meters per second. If you measure the speed of sound to be 342 meters per second, then the absolute error would be 342 minus 352, making it negative 10 meters per second. You are off by 10 less, hence the minus sign. Percent error takes absolute error and calculates it as a percentage of the accepted value. For your measured speed of sound, having negative 10 meters per second absolute error, if we divide that by the accepted value for the speed of sound, which is 352, and multiply it by 100%, then we have the percent error of minus 2.84%. The minus sign means you measured less than the accepted value. The last measurement that we will look at is percent difference, which is very similar to percent error, but does not compare your measurement versus an accepted value. Rather, what it does is looks at your multiple measurements to determine how they differ as a percentage. In this example, you measure the speed of sound twice, once at 342 and once at 348 meters per second. The percent difference would be determined by calculating how much the two differ from one another, and then dividing the difference by the average of the two measurements. Then you would multiply by 100% to get the percentage. As you can see, in our example, 342 minus 348 makes 6, and the average of 342 and 348 is 345. The percent difference is 6 divided by 345 times 100%, which makes 2% difference. Note, we do not know which is the correct value, so we take the absolute value, and if the percent difference happens to have a negative sign, we would just ignore that.